Hi, so in this video we're going to start on the finishing process for this. I appreciate it doesn't quite look like it's ready for that yet, but bear with me. And we are initially going to start by cleaning up all of these interior profiles. So we go back to the machining space and we're going to define a new setup stage, which we are going to call finishing. And we are going to define a contouring path at this point. We're going to use the 3D contouring tool. We're going to stick with the 5mm spherical mill because the radius of a lot of these fillets is actually 2.5mm, which is very convenient for our needs. And we are going to grab these contours and we're going to define them as our contour parts. So I'll just take a second to select all of these. And we now have our first one defined. So we will go to here and curve. And we want our cutting tool to be on this line instead of inside it, because that's the offset that we've got. And we will quickly set the 6th axis control again and then go back to generate the toolpath, and we should have a fairly clean toolpath from here. We'll go to the axis map just to double check, build the graph, update the toolpath, and we'll now simulate this. Fortunately, due to it just being a simple contouring path, it's a very quick simulation. So if we click run, we'll see how it's swept around there and there's no excess material left over. We'll do a quick verify compare, and that entire region is now a nice green. There's going to be a couple of small, very clean up parts to do in here, which is not the end of the world, but it is worth taking note of. However, we can now copy and paste this particular solution for all of these panels all the way around. So I'm going to quickly go around and select all of these. I'm just going to pause the recording whilst I do so. And once I've got that ready to go, I'll come back to you shortly. Okay, so as we can see here, I've now selected all of these exterior curve lines. I've kept them as separate curves where there's the small overlap regions here that we'd previously highlighted with our complex plane. So we can now go into generating that toolpath, and we can just double check the axis map again, which we should be becoming extremely familiar with throughout the course of this video. We update the toolpath and we are now going to go in for a quick simulation. And we're going to check the verify compare tool, and we can see now around all of these bases we've now got a much cleaner, much closer to the perfect 0 mark than we did before, which is ideal. Although I've noticed that we've not seen anything much going on with these bits, so we're going to go back, and the reason for this is because these final couple of tool passes are not set to be on the line, they're set to be inside the line, which is very much my mistake. So I'm going to regenerate that. This is something that's absolutely integral whenever you're dealing with contouring as well, so it's a mistake that's worth noting and very much worth picking up and learning from. So let's go back into simulation now and we'll rerun this. Let's just get a don't know why that's flipped around. Sorry about this. Let's quickly rerun now. And once that's run, we'll now do a verify compare, and we can now see that all of these regions are lovely and clear and green, which is exactly what we're after. So we're now getting pretty close to a more viable finished part. There is obviously a very small amount of excess deflection here. We can go back and we can refine this scalloping paths. That's not, scalloping, these complex paths by enabling the scalloping check on them as well. But I would like us to get to a stage where we've got a more complete part before we start fine-tuning the last details of it. So we are now going to start looking at cleaning up all of these profiles as well. So I am going to go back and we're going to use a 2D contouring path for this time. So we go with 2D contouring and we're going to select each of these curves. So if I remember correctly, all of the bores, yep, they had a little bit of excess on them. So we're going to go around through all of these on the two separate level planes that we had determined before. And we're going to select each of them and we are just going to clean them out, get them to final size. So let's just grab the last of these and select those curves. Okay, and obviously we want our contouring to be on the inside of these, but we don't want there to be any excess to account for. We're going to change the tool on this from a 20mm cylindrical mill to, we're going to go with like a 4mm. We'll go with the 4mm cylindrical tool. So if we select this one for now, and then we change the diameter on it accordingly, and set it as a new tool. We'll keep the lengths and everything the same for now. And we do the last little bits we need to do before we run it. Okay, so we're going to have to quickly go through that toolpath. Update and run now. Now if we simulate this, we should see all of our bores get cleaned out and brought to the correct size, at least all of our deep bores, and then the shallow bores we'll do in the next pass. Just very quickly check compare. Lovely green surfaces there. This is exactly what we want to see. Now again, as I say, the difference between the solid model like this and the voxel model like this is much closer to actual real world precision, whereas the voxel model is significantly better for more organic forms because it's volumetrically defined instead of working off of solids. It does mean that it lacks a little bit of the final precision compared to this though. So this for hard material surfacing is exceptional and cannot be beaten in my opinion. So I'm going to turn that back off and we're going to go back now and we're going to duplicate this 2D contouring path and we are going to redefine each of these parts that we're going to be cutting, because we're not going to cut those ones. We are instead going to go from beneath because these parts have got curved lines to them. So we're going to select that curve. We don't really need to go from underneath for these ones, but we've got it, so why not? And we are going to grab that one as well before I forget. Don't know why I keep forgetting that one. It's every bit as important as the others. We are going to define our top level, and that should see us done for that. So fixed vector is good. Generate the toolpath. Give it a second to think about it. And then we check the axis map and we should be good to go. Sorry, that's my dog shaking his head in the background there. Okay, so go to the axis map now to try and resolve these minor issues that are coming up. We build the graph and we update the toolpath, and that, I believe, is us ready to go. So we now go back into the simulation environment, quickly run through these, and we check. And we've still got a bit of blue in this one, which is interesting. So I think we're going to have to quickly work through this bore again. The rest of these bores all look good though. So let's focus on this bore, see what we can do about resolving that problem. So at the moment we have got, right, so we've selected this face and I'm just noticing there's a slight deflection out here. So what I'm going to do is I am going to set another contour here. Let's go using this. No, not that line. We'll use this line here. Okay, so we've still got the same, roughly the same contouring profile, but it's just in a tiny bit from there. We will duplicate this operation and we'll set this as a separate curve to cut. We'll delete that because there is going to be a small amount of taper in there. So I'm going to set this as the top level, and I'm going to very quickly measure this because obviously we don't want to chew the taper that's in there just in case it becomes important later on. But that's what, that's 0.9 of a millimeters. So if I set the bottom level on this to 51 millimeters, that should see us largely sorted. So I'm going to generate the toolpath accordingly. And we are going to look at the axis map. Build the graph, update the toolpath. Then we go back into the simulation space. Sorry, these camera flips must be very disorienting. I do apologize. We simulate that last path. Verify compare. We see that's all coming up green now, which is great. There is a tiny amount of blue there because I used a sharp edge tool, but most importantly I don't want to see any red coming up in there where it's cut too deep in there, and I don't know what the angle of deflection on that is. But we now have generally a very clean looking model there, which is absolutely fitting most of our needs. So we can start looking at the final part of the finishing process, which I'm going to split off into a separate video at this stage, which is going to be the exterior profiling. There's also going to be a little bit of the optimized toolpath in the optimized planar toolpath in there as well. And there's going to be some final finishing planes and then a little bit of contouring, and this series will be complete. So I'll see you in the next one.